Harris. Now, last class we have studied about supplementary physical quantity. So today we will discuss about supplementary physical quantities and its dimension and about the application of dimension. So first of all, if we think about supplementary physical quantity, so we know that supplementary physical quantity, that is radian or steradian, plane angle and solid angle. So these two angles having units only, they don't having any dimensions. So here we will check about plane angle. So just we wanted to find the dimensions of plane angle. So plane angle, we know the plane angle, its unit, so its unit be radian, units having radian, but they having no dimensions, no dimension. Why they having no dimension? Because we know that the plane angle is the ratio of the circumference to its radius of a circle. That means we know this one is the circumference of a circle to its radius. That means let you just suppose that circumference of a circle, this one is 2 pi r. This one is your circumference. You just let it be L, and then divided by radius. So your radius will be r. So what you will get, r and r will be cancelled. Therefore, this one is only 2 pi. So 2 pi is a constant. This one is constant. This one is constant. And this constant having no dimensions. Alright. So accordingly, if you wanted to find the dimension of solid angle, so you can see here that dimension of solid angle sterad, that is steradian, and they don't have dimension, that is no dimension. Why is this? Because see about solid angle. So solid angle is also is the surface area of a sphere to the square of its radius. So the surface area of radius b, surface area of this sphere, that is 4 pi r square, and divided by square of the radius. So from here you can see that rx square and rx square be cancelled. So how much be there? So right now this one is 4 pi only, and this 4 pi is also constant. This one is also constant. That means no dimension. Alright. So these are two examples which reflects units only. There is radian and there is steradian, and all these are units. These are units, but they have no dimension. Okay, but right now I just wanted to take some examples, that examples having no units, no dimensions. Like that, if we talk about refractive index, so now in refractive index, first of all you know that from where this one came, refractive index. So basically refractive index came from second one having mu2, so that the product of the refractive index of the medium and sine of the angle is equal to constant. So from there mu1 sine I, suppose I is the angle of incidence, so sine with angle, so therefore mu1 sine I is equal to constant, and when it enters in another medium, suppose it is denser, where if it is enter from either rare to denser or denser to rare, so accordingly when it enters into second medium, so there will be, if its angle be R2 and refractive index be mu2, so sin R2 mu2. Otherwise, if angle be I2, so sin I2 into mu2. So from there we can find out there is a mu, and its mu, this mu is index of the medium. So you can see from here that the dimension of refractive index. So the result that there is no dimension as well as unit. So how's this? So just I am going to be brief. If suppose there is a medium interface, this one is a media interface, this one is this line will be, and if light, this one is normal, if this one is I1, and if this one is I2, refractive index of this medium B, if you suppose this one is mu1 and this one is mu2, so what would be there? Here to take sine of product of the sine of the angle and the refractive index of the same medium, that will be constant. So right now from here you can derive an equation that mu1 sine I1 and this one is equal to constant. So you just make it equation 1. Accordingly for the second medium, so its refractive index will be mu2 and sine of the angle, so its angle be I2, and this one is equal to also constant. So this relation will be there, and using this relation whenever you will see, so you can see here both are constant, so this one is equal to this one. Therefore you can write here, therefore mu1 sine I1 is equal to mu2 sine I2 from there. And now from here there is the sine I1 by sine I2, and this one is equal to sine I1 by mu2 by mu1. Now if this medium is here, and if this medium is whatever, any medium in here, so any medium, you just write down any medium. So what you can calculate for here, mu1 is equal to 1, and if you suppose this one is mu, so what we will here, your mu1 will be 1 and this one is mu. So mu by 1 will be here. And both are sine and this one is angle. So dimensionally the angle will be here. So for few angle, this one is I1 by I. And you know for angle, you have unit here, but there is no dimension. So whatever the unit will be in radian. So if you suppose that its unit be in radian, therefore this one will be also in radian. So what happens from here? That will be cancelled. That's why mu having no unit and mu having no unit and dimension. That means what? You can still say that mu is unitless and dimensionless. Unitless and dimensionless. Right? So accordingly, we can calculate one more example. Suppose someone want to find the unit and dimension of unit and dimension of unit and dimension. Unit and dimension of restitution. Restitution is basically represented by E, small e, and the magnitude of a small e is vary from 0 to 1. So this one is vary from greater than equal to 0 and less than equal to 1, like that. Okay. Basically, what is this? Coefficient of restitution. So basically your coefficient of restitution is velocity of separation to the velocity of approach. So you're seeing that in numerator and denominator both are velocity. So the unit of velocity is meter per second. So in up there is meter per second and there is also meter per second. So what happens from there? That meter per second and meter per second will be cancelled. That means it having no units, and if having no units, there were no dimensions. That means unitless and dimensionless. Quantity. So this one. Now, then dimension of Planck's constant. So dimension of Planck's constant. Basically, it is represented by H. So there is a relation of Planck's constant with energy that E is equal to Sc by lambda. Here c is speed of light. This one is speed of light. Lambda is wavelength. And E stand for energy. So now from here, where h is Planck's constant. So you have to find this h. So from here, like that E lambda by C. So write down the dimensions. Therefore you are seeing here, this one is energy. The dimension of energy is basically the product of force and displacement. So you know the dimension of and its product of force and displacement is ml2 t minus 2. So here you can write down directly. Otherwise you can write down by splitting this one, but the correct is that you just write down directly. For this one you need to make proper proper reason for that one. Okay, so you just keep yourself in practice. Therefore E is directly ml2 t minus 2 dimension of energy, this one, where the wavelength is a distance. Okay, so its dimension is L. Okay, and then divided by C. C is speed of light. So speed of light, this one is meter per second, so Lt minus 1. So right now this one is Lt minus 1. Now you can see here that L and L will be cancelled, and then from here your 1 T will be cancelled, because T minus 1 and there is T minus 2. So this T minus 1 will be cancelled by T minus 1. That's why the dimension of your Planck's constant h, that will be ml2 t minus 1. Right? Okay. Then again you can also find the dimension of just like a linear momentum, charge, energy, just like there from here, this one is ml2 t minus 2. So if suppose you wanted to find the dimension of linear momentum, so how you can find this one? So just here I am going to write directly linear momentum. So the dimension of this one, linear momentum, basically it is a product of mass and velocity. So write down the dimension of mass, this one is m, and the dimension of velocity, this one is L, t minus 1. So finally dimension of linear momentum is ml t minus 1, and this one is your resultant. So from here you can find out this one. Right now next class we will discuss about application of